Welcome back everybody to Geology 101. In this unit we'll talk about the coasts. Now we know already that the coasts are important. Why? Because that is where most of the world's sediment is deposited, where most of the world's sedimentary rocks come from. But we're going to go into a little bit more detail here about how the coasts are so important to geology, even though they make up only a tiny fraction of the world's total area. Okay. So the first thing we'll do here is talk about our goals for the unit. The first is to be able to describe what the coast looks like. What are the different parts? What does it actually look like if you were to cut through the coast with a knife? You pull it out, you look at it from the side, what would you see? The next part is to understand how plate tectonics might control what happens at the coast. The next part, related to understanding plate tectonics, is to distinguish between active and passive margins. These are going to be our different types of coasts. Next, we'll want to explain some of the mechanisms that control how water moves around the Earth, including things like waves and tides and ocean currents. And then finally, we'll put it all together. We'll talk about how the oceans shape continental landmasses. So this first section will give us a broad overview of Earth's ocean system. Okay, so why is this important first of all? Well, Earth, if you could only describe it one way, would be the water planet. I can tell you from experience, all the other planets are extremely jealous of Earth, and given the choice, if you could pick any planet to live on in the solar system, the choice would be very clear. Why? 70% of the Earth's surface is covered in ocean, part of what makes it the water planet. We have 5 major oceans, going from largest to smallest. We have Pacific, Atlantic, Indian, Southern, and Arctic. Southern may or may not be new to you. Average depth is about 4 kilometers, 4,000 meters, or about 12,000 feet. And the average continent elevation above sea level is going to be about 2,700 feet. So these are our major oceans. Going from north to south, we have our Arctic Ocean up in the Arctic near the North Pole. We have North America here, Atlantic to the east, and Pacific to the west, Pacific being the largest ocean. We have the Indian Ocean here, right off the Indian subcontinent, and something that may or may not be new to you is the Southern Ocean down here near Antarctica. Now, where these oceans intersect with the continents, the continental land masses, we have coastlines. Going to be about 372,000 miles worth of coastlines worldwide, about 1.5 times the distance to the moon. And, well, there are a couple different ways to measure this. It's actually an interesting problem, which we'll talk about more in a bit. A good 40% of the global population, billions of people, lives within 60 miles of an oceanic coast. These tend to be densely populated areas. This is significant for reasons that we will get into in a bit. And most countries, about 80%, are going to have some form of oceanic coastline, even if it is just a little bit. Now, this is a little bit of a tangent here, but the problem of how to measure a coastline is a much more interesting one than you might think. For example, the answer that you get for the total perimeter, the total size of the coastline, depends on the size of the measuring stick that you use. What would this look like? Well, we have Great Britain here, and we're going to outline the entire coast. And if we use a really, really big measuring stick, you notice there's all these little parts that are sort of cut off. But if we use a smaller ruler here, a smaller measuring scale, then all of a sudden, actually, our total coastline gets a little bit longer. And it gets a little bit longer still as we make our measurement tool shorter and shorter and shorter. Right? If we put it into numbers, then you can see that we get actually wildly different measurements, right? So as we measure with 100-kilometer rulers, right, putting them side by side, go around the whole coast, we would get 2,800 kilometers worth of coastline. But as we decrease the size of the measurement down to 1 kilometer, we could get something over 8,000 kilometers worth of coastline. In other words, it goes up rapidly. And in this sense, you couldn't exactly call the coastline as a one-dimensional object like a line. It would have to be something that has a fraction of a dimension assigned to it, something called a fractal dimension. Not vital to the unit, but something cool you might think about. So let's take a look. We have our map of the world here, and the more red and orange a country has in its color, the more coastline it has. Now, we just talked about how hard it is to measure coastline, but we can assume that whatever measurement method was used consistently for each of these countries. Same size measuring stick for each one. Okay, so you can tell right away that most of the countries in the world are going to have some form of coastline. You might be able to tell right away that regions that are landlocked tend to be in the interior of the Middle East and in Africa. And, well, you might take a second here to think about which of these countries you would expect to have the most total coastline. What do you think is going to be the country in the world with the most, and then maybe the second most, and then maybe the third most? Well, here is our top 10 list, the top 10 longest coastlines in total for each country in the world. Now, we have Canada, Norway, Indonesia, Greenland, and Russia. What do these have in common? Well, actually, what do all of these countries have in common? We're looking for the most part at island nations, or nations which have a lot of islands, right? Something like Canada. Well, the reason why the coastline is so long is because we're counting the coastline of not just this mass here, but also of all these little islands, right? A place like Indonesia, right? We're counting not just the coastline of the big land masses, but of all the little ones too. And it is through that process that you get countries which have such huge coastlines. So what about U.S. coastlines specifically? Well, we got about 12,000 miles for the coastlines in the U.S., going to be about half the distance around the Earth at the equator. A good 40% of the United States population lives close to or even along these coasts, and it's going to be about half the states which have oceanic coastline. Gets a little complicated depending on whether or not you include the Great Lakes. Okay, so you might take a second here to look at this image in the background. We're looking at a coast on the U.S. and try to figure out, is this west coast or is this the east coast? It's going to be one of those two, and even if you don't know for sure, what makes you think that it's one or the other? What are you really looking at here? So let's go ahead and take a look at our map here. The states with dark blue are going to have some sort of ocean coastline. States up here with light blue have some sort of Great Lakes coastline. New York is lucky enough to have both. And you might ask yourself the question here, which of these states is going to have the most total amount of coastline? What would be number 1? What do you think would be number 2? And what do you think would be number 3? Well, now I sincerely hope that you said Alaska first. Again, the sheer number of islands here makes it much, much larger in terms of total coastline than other states, things like Texas. Florida, you maybe could get as number 2 because so much of it is touching the coast. And then actually, California is going to be number 3, just so much coast over on the west. Okay, that is it for section 1. In section 2, we connect 2 different topics here. So there's all these things we've been talking about with coast, who has what coastline, and maybe what kind of coast you have in what place. And we're going to connect that back to the larger process of plate tectonics.